Okay. So let's move on to phase 2. And phase 2 is all about sort of doing a 180. Equations and variables. So this is 90% of you would say that this is definitely easier. And the only reason really is that it's more familiar. If something's more familiar and you're used to it, then it's going to be easier. So I'm not going to assume that you already know how to do all these things. I'm going to start out at a place that is extremely simple, and you might think, oh, this is going to be the easiest thing ever, and I don't have to work anymore with that. But be careful that you don't take it for granted, and then suddenly we're doing stuff that you're not that familiar with anymore, and then phase 2 doesn't go so well either. So to compensate for the difficulty of phase 1, we want to make sure that we do well in this phase. So all we're going to do is look at examples. I have my example sheet, lecture 1. And by doing all of those, we're going to see all the various things that you want to see. So if you want to laugh out loud, the first question, you're welcome to, but maybe you haven't done math in a long time. I'm starting at the beginning. So if I have a basic equation, something like this, a over 4 equals 5. What is an equation really? What is a variable? A variable is simply, usually a letter, simply a placeholder for a number. So there's a number hiding behind a. And the equation tells me, gives me some information about what the value of a, in this case, should be. The value of a should be such that when I divide it by 4, I have to get to the number 5. Now, that's pretty easy. Everyone can see that a should be 20. But if I pretend that this is actually a more complicated equation, what are my rules that I can apply to an equation to try and simplify it? Let's say, what can we do to the equation? One thing we can do is we can multiply or divide, whichever one you want, by a non-zero number, and I have to do it on both sides of the equation. Now, in this case, it does seem like more work than is necessary, but I'm trying to practice on something that I can already see the solution to verify that it does work if I do something like this. So in this case, I want to make this even simpler by doing something and just having a on the left, and everything else should be on the right. Hopefully it's just a single number. So what can I do to get rid of this 4 in the denominator? I can multiply both sides by 4. I have to do it on both sides. That doesn't change the information that the equation has. Now 4 divided by 4 gives me 1. I just have a on the left. And I can essentially read off the solution from this version of the same equation. It's the same equation. If I do this, multiply or divide on both sides, I'm not changing the essence of the equation. I just want to make it look so nice that I can just read off the answer. The other one is an example 2, where I have my variable name is b, plus 2 equals a. That means I'm looking for a number b that's represented by b, some number hiding behind b. And if I add 2 to it, the answer should be a. What else can I do to my equation other than multiply and divide? I can add or subtract by any number, or add and subtract any number, not by, on both sides of the equation. In this case, I can easily see, well, b has to be 6. But if it comes from a more complicated equation where I can't read off the answer, I want to apply these two rules so that I make the equation look so nice that I just read off the solution. So I want my variable alone on the left. What do? I think you're used to writing it underneath. And I'm going to subtract 2 on both sides to get rid of this 2. He's not a variable. He has to go. So by subtracting 2, I only have b on the left. What do I have on the right? The 6. It's the same information, essentially the same equation, but that one looks even simpler. I can just read off the answer, b equals 6. So these are the only 2 things, essentially 4 things, multiply, divide, add and subtract. The only things that I can do to simplify an equation. And I can do them in steps until I get to the point where I just read off my answer. If I only apply those 4 things, then I'm not changing the essence of the equation, I'm just making it look better. And in my experience, we easily forget what we're actually doing. This is the same equation as this. It just looks nicer. I'm not changing the equation. So if I combine them in something like number 3, where my variable name is now n, 3 times n minus 1 equals 14, then I'm going to use a couple of steps to try and get n alone on the left and my number on the right. Same equation, but this one is so straightforward that I can just read off the answer. That's my goal. So I'm going to add 1 on both sides to get rid of this one. And I'll have 3 times n equals 15. What do I do to get rid of this 3? Well, it's multiplication. So I'm going to divide by 3. As long as I do it on both sides, I'm not changing the equation. I'm just making it look nicer. So now I have n alone on the left and a 5 on the right, and then read off my answer. So I'm trying to emphasize what we're actually doing. We're only trying to change how the equation looks. We're not trying to change the actual equation. If I have more of a word problem setting where they don't give me the equation, they say 2 times a number increased by 1 is 15. What is the number? Now, they're not telling me to use an equation, but let's use an equation. So let's say x represents, or let x represent the missing number. Then the information that they give me, I'm going to try and capture that information with an equation. What is the equation that captures the information that says 2 times a number increased by 1 is 15? So my equation is essentially a sentence. It's just written without words, but it reads the same. It has the same information. What would we say? Well, 2 times my number, so 2 times x, increased by 1 has to be 15. Everyone happy with that? So this equation has exactly the same information as that first sentence. So now I'm trying to find x. Subtract 1 on both sides to get 2x equals 14. Divide by 2 to get x equal 7. And I just used x to find the answer easily. I guess I have to do a little sentence just to say, okay, this is my answer. There was no x in the question, so I can't leave this. This x means nothing because there's no x in the question. I just used an x to find the answer. So I'll say, so the missing number is 7. Now we are doing simple examples for now to just try and emphasize what we're doing, not get caught up in the complexity of the actual equation. This is all I'm doing. Let's try number 5. Now they give me an equation. My variable is p. And I want to find the value of p. So the first thing I want to do is simplify this left-hand side. The 2 I can multiply into the bracket and have 2 times p plus 8 equals 7p plus 2. Now I want all my variables on the left, or on one side. My preferred side is the left. And everything else that doesn't involve the variable should go to the other side. So I can only subtract, add, multiply, and divide on both sides. What can I do in this case? It's sort of like a game. I have my rules. I can only do 4 things. What can I do to make this look so simple that I can just read off the answer? What can I do first?
Subtract 2p on both sides.
Okay, so she says she wants the p's on the right. Doesn't matter as long as they're all together. So then I have, so for now I'm going to emphasize the steps by just writing out all the details. I know after we get used to it, or if you're already used to it, you don't have to write every step. But just to make sure everyone's on the same page, after I do one thing, I'll write down my new version, not my new version, my new look for the equation, and then I'll figure out what my next step is. So right now I have 8 equals 5p plus 2. Everyone happy with that? I had 7 p's, I took away 2, so I have 5 p's left.
Now you subtract 2 from both sides.
Now, before you continue, I just feel much better with my variables on the left. It just feels better to me. You don't have to do it. It's like my security, no blanket, but my security step. I like my variable on the left because you read left to right. So eventually I want to read p equals some number. But it's not, it's just for me. So now you said subtract 2 on both sides. 5p is equal to 6.
You divide by 5.
So this 5 has to go. I can divide on both sides. P is equal to whatever that is. 6 over 5. You can write it as a decimal. I really don't care. 1.4 or 1.2. Doesn't matter. Doesn't matter how you want to write this, but I've just manipulated my equation to look better. It's the same equation as this original. It just looks so nice that I can just read off my answer. That's all we're really doing. I'll do one more and then we can move on. Over these simple examples, I'm trying to emphasize what we're actually doing. We're only applying those 4 basic rules to make the equation look nicer. Now I have 7x plus 3 over 2 minus 9x minus 8 over 4 equals 6. And now we're not going to do many of these just for the sake of them. We're not doing pre-calculus. I'm just doing enough to emphasize what we're actually, how we're actually working with equations. Now, the first thing that bothers me is the fraction, the denominators. They're just making things more complicated or look more complicated than it needs to be. So what can I multiply with on both sides to get rid of all the denominators? 4. So let's say here 4 times everything on the left and then 4 times everything on the right. So here I get, let's write down the steps so everyone is sure what we're doing. 4 times the first time, 4 times the second time. And the right-hand side is 24. Fractions are always just unpleasant. So I want to get rid of that as soon as I can. Well, these 4's cancel, so that gets rid of that fraction. This one, this is 2 times 2, so one of the 2's cancels with the bottom 2, and I have 2 times 7x plus 3 minus, I have to remember the bracket because of this minus, equals 24. Everyone happy with that? Now again, you have different backgrounds, different memories. My memory is terrible. If I don't do something often, then I just forget. So I want to make sure everyone understands how to simplify equations. Now I'm going to multiply the 2 into this first bracket to get 14x plus 6. There's a negative 1 there that I have to multiply in to get negative 9x. 2 negatives make it positive, and that equals 24. Then I have 14 x's and I take away 9, so I have 5 x's left. Just simplify the left-hand side first. That looks like 14 equals 24. So I can subtract 14, and I have 5x equals 10. Divide by 5 on both sides. X equals 2. Same equation. It has the same information, but by applying one of those rules one step at a time, just making it look more obvious as to what the solution is. Any questions on number 6?
Can you put it on the board for a bit?
Can I leave it on the board? Sure.
Thank you.
What's another way that you could, instead of
Instead of this?
using the 4 there? Yeah, like what else could you do?
You can put these together over a common denominator
Yeah,
first. In my experience, and it's just preference really,
Yeah.
getting rid of the fractions as soon as I can just reduces the risk of making mistakes. If you happen to be one of the 1% of people that like fractions, then you want to keep it as much as possible. It's all the same. You can apply any of those 4 steps in any order you want. My personal preference is just to get rid of the fractions as soon as I can by just multiplying something that would cancel with these guys. Yeah.
Oh, okay, so it's not multiplying by 4x.
No, this is in times.
Oh, okay, that's why I was confused. Okay.
See, x has little curls to it.
Yeah, I see now.
Otherwise, you would get confused. I've done an x. This is an x. See, different. You can also write it with a dot if you want. The dot notation is actually there to eliminate that confusion. If you write your x's like a times symbol, then you don't want to mix those up. So this is just one way, whatever works for you, as long as you always do one of those 4. So number 7. This one and number 9 sort of hints forward to phase 3, where we're going to use formulas like this. But it's still an equation. The equation S equals P plus P times R times T. That is the simple interest formula. Oh, it says there. As the formula for the value S of an investment, principal P, simple interest rate R for T years. It doesn't matter. I just have an equation. I'm interested to express P in terms of S, R, and T. So what I want to do is I want to solve for P. And I pretend all the other things are numbers. In my equation, which is S equals P plus P times R times T. I'm going to write it the other way around. because p is my variable, so I want to eventually write p equals something else, so that I can just read off the solution as if I had values for r, t, and s. So one thing is I can take p out as a common factor, sort of the reverse of multiplying it back in. Now, how do I get p alone on the left? This is just one thing. I don't even look at what's inside this thing. I have to divide by this thing. That will cancel it. So then you put it up here. Those brackets just keep all of those together. It doesn't matter what's inside the brackets. And then I have p equals s over what's inside the bracket, 1 plus r times t. My rule is applied to this bracket really, dividing both sides by the same thing. Doesn't matter what that thing is or how complicated it is. Okay, number 8. Should we do number 8? No, let's just do number 8. Number 8 is more for next time, so let's do number 8. We're going to do enough of them next time. Number 9. Let's stick to this formula equation business. Now I have this slightly more messy. I'm going to use square brackets here just to distinguish between the two bracket types. Anyone seen that guy before? Just out of curiosity. You don't have to. Phase 3 is going to be full of it. But in a good way.
What is it?
This is the formula for an ordinary annuity. As if you make monthly payments, how does your money grow, compound interest, things like that. Phase 3. It's a little preview. And in that, we want to move things around and make this equation look different depending on which thing you want to find. In this case, this is my accumulated amount, my future value, if you will, how my money grows after a certain length of time, depending on my investment, depending on my interest rate and the number of months, things like that. But if I want to calculate another part of it, given the values of all the other letters, for example, I want to solve for r. How would I do that? Well, what can I multiply by on both sides to get rid of this fraction? I have to multiply by I, because then the two i's will cancel. So then I have I times s equals r 1 plus I to the n, that's an I, minus 1. Let's write it the other way around. This is my variable. I like my variable on the left, just make me feel better. Now, what do I do to get r alone on the left? It doesn't matter how complicated or messy that equation looks. It's still r times something enclosed in these square brackets. So what I can do is I can divide by that something. It doesn't matter what's inside, but I have to do it on both sides. So technically, don't do that in the test, but I'm trying to emphasize that it doesn't matter what's inside the square bracket. It doesn't matter how messy it is. It's still r times this whole thing. How do I get r alone? By dividing on both sides by that whole thing. And then I get r equal, because these guys cancel, I times s over the square bracket thing, which was that. So I'm just making the equation look like I want, by applying one of those rules in a stepwise way. The main reason why I do these examples here is because when we get to phase 3, it shouldn't be completely unfamiliar. It's still just an equation. In phase 3, I'll have specific values for these guys, except for one of them, and I want to solve for that one. But it could be anyone. And I'm still only using my 4 different options that I have available. Add, subtract, multiply, and divide by something on both sides. Any questions so far? Questions so far? Very easy, familiar. Still, I think everyone's different, so I can't tell you what to do, but be careful that you don't think it's that easy, you don't have to do anything. Still try and look at the homework systematically so it doesn't pile up, and it's easier that way. Let's read number 10. Wanda plans to save 1/10 of her salary each week. If her salary is $350 weekly, how much will she save in 6 weeks? What can I do to calculate that in a nice, clear, systematic way? What should I do? If I break it up into smaller steps, what can I do first?
Find out how much 1/10 of 350.
Okay. So if I say, let's say in words here, 1/10 of $350. How do I calculate that? A fraction of a number. What do I do?
350 times 1 divided by 10?
If I see something like this, fraction of a number, that's multiplication. So it doesn't matter how you write the multiplication, it's still multiplication. It's always multiplied. So what would that be? I pick a nice fraction.
35?
35. It's not hard. But if it's more difficult, you can do it in the calculator. Doesn't matter. I see kids in the middle grades when they start to introduce word problems just being completely confused by that. But it's so simple. It's always the same. Fraction of a number is multiplication. So now, what does this represent?
1 week savings.
This is our savings per week. So how do we find our total savings? Total savings?
Times it by 6.
That's by 6. It's so simple, I almost feel embarrassed to do it. What is 35 times 6?
210.
210? Sounds pretty confident. All right.
Instead of just doing 1/10 multiplied by 350, could you put 1/10 multiplied by 350 over x and then cross multiply?
Yes, but there's no need to make it more complicated than it is. We're going to do those things in a second. You can. I just don't want to do it here. There's no need to be confusing here. We're going to do those things when we get to 13. Not to worry. Not to worry. If it doesn't, yeah. I always am looking for the simplest possible. This, so simple. That's the simplest I can do it, but if you want to do something else, or you're used to doing something else, do whatever you want. 11. In planning for a conference on successful small business practices, the organizers are anticipating that twice as many men as women will attend the conference. If they are expecting 600 to attend the conference in total, how many men and how many women are likely to attend. So now I want to practice the variable equation method, if you will, or way of thinking. That when things become too complicated, I want to define a variable, I want to set up an equation that captures the same information, and by solving that equation, I'm going to answer the question. So let's define a variable. One should be enough. Let's focus on the man or woman. Which one do you want?
Women.
Women. Let W be or represent the number of women that will attend. Why do I need to define a separate new variable for the number of men, or is one sufficient? So can I say the number of men? What is the number of men if W represents the number of women? 2W? So I don't need to define a new variable. If I can keep down the number of variables, that'll make my life easier when I get to the equation phase. By knowing the number of women, the number of men can be expressed in terms of that variable. Now I want to capture the information that I haven't used yet. And that is, they're expecting 600 people to attend the conference. So let's say here, total attendance. How do you spell attendance?
ATT.
I do math, I can't spell. Is that right? I can only do one thing. Spelling is not it. I remember when I was little, it took me an age to remember how to spell skeletons. Couldn't do it. Didn't help in English, but it's my first language, but still. Equation. Let's say an equation here.
2W plus W equals 600.
So the information that they're giving me is captured by that equation, by adding up the total number of people using my variable, men plus women. And on the other hand, they tell me it should equal 600. Now, I'm not saying this question is so complicated that we have to do this, but we're trying to practice this method with reasonably simple examples that you can easily verify that your answer is correct. So now I have 3W equals 600. What do I do with this equation? I divide by 3, and I get that W equals, hopefully, 200. W equals 200. Same equation, I'm just making it look so nice that I can just read off the answer. Do I stop here? In word problems, I don't want to stop here. The W was for my benefit only, to try and find the solution. I want to write my answer without using the variable. So I can say there are 200 women and obviously then 400 men. Just a little sentence at the end to say, okay, this is the answer to this is the answer to the problem. The problem, the little question there doesn't talk about the W. The W was my method to find the answer. So I have to go back and say it without the W.